In this video, I am going to talk to you about the area of these rectilinear shapes, apart from the circle, which is a circle. All of these formulas, by the time you've reached year 9, should be fairly familiar to you. If you are a little bit rusty on things such as what an area of a trapezoid is or the area of a circle, then you'll need to look up other videos specifically for those shapes. So let's just have a look. All these formulas on here, we need to learn and we need to understand how to use each one to work out the area. The area of each of these shapes is the space inside that shape. These are all two-dimensional flat shapes. So what's important about these 4 shapes here is they all incorporate a height. And the height is always found at right angles to the base that you're going to use in the question. Sometimes they throw in a red herring, such as putting a slant height in, but you need to find a height that is perpendicular to a base to be able to calculate the area of these shapes. So the circle, again, we've got pi r squared, and these we've got the square and the rectangle s squared. Obviously it's got sides all the same. You can still use length times width for that if you like. This is length times width. These two, you've got the rhombus and the parallelogram. The area is base times perpendicular height. Triangle, half the base times the height. You can also write this as the area equals base times height divided by 2. These two statements or formulas are exactly the same. It's just different ways of us writing it. Same with this one. You can actually you can divide by 2 at any point, right? As long as you only do it once. So you can actually work out the height multiplied by a plus b, all divided by 2. That's what halving means, okay? So I'm just going to run through an example of some of these shapes with you. So if I'm going to calculate the area of a square that has sides 4 centimetres, then our area becomes a equals 4 times 4, or 4 squared, and we are in centimetres, so it's important that we write our units, 16 centimetre squared. Let's look at a rectangle. Let's suppose we have a rectangle with a length of 4 and a width of 2, and we're in metres. Length times width is what we do to work out the area, so we write the formula down and we substitute the values in. 2 times 4 equals 8, and then we put our units, 8 metres squared. Okay, so on the rhombus and the parallelogram, we need to have a base and a perpendicular height. I'm going to put some other measurements in there as well. Sometimes the height is given outside of the shape. Same with a triangle. Depends on what kind of triangle you've got. You're looking for a height that goes at right angles to a base that you pick, that goes across one whole length of the shape. So let's imagine this dotted line represents a height on the outside. Let's suppose I gave you a perpendicular height of 5 centimetres and a base of 3 centimetres. And perhaps maybe I might give you a slant height of 3.5 centimetres. All right? Actually, that can't be real because the hypotenuse would be longer. Let's just make this up. 13.5 centimetres, right? That sounds more realistic. Now, let's look at this. Well, okay, base is 3, but the height's on the outside. But that's okay. We just go 3 times 5, which is 15. Oops, I'm going to write 15 then. 3 times 5 equals 15 centimetres squared. Okay? All right, let's move on to a triangle. Again, the height could be on the outside. You've just got to look at where's that perpendicular height. Let's have a height of 6. Let's go kilometres. And the base, let's suppose the base is 2,000 metres. Okay, we clearly need to have the same units when we're working out area. So it would be appropriate for me to look at that and do my unit conversion and say that's 2 kilometres. So when I work out the area of this triangle, I'm going to do a half of 6 times 2. Okay, 6 times 2 is 12. Half of 12 is 6. So I'm dealing with an area of 6 kilometres squared. Trapezoid. Let's do the trapezoid. I don't want to stand over the actual shape itself, so I'll stand over here. But the way we look for the perpendicular height is we're looking for a set of parallel lines, a pair of parallel lines. So A and B have to be parallel in this shape. So let's pick some numbers. I'm going to go, I'll do my working over here, but I'll write the numbers over there. Let's go height of 4 centimeters. A can be 1 centimeter and B can be 4 centimeters. Okay, so I'm going to substitute it into the formula. So I'll write the formula down. A equals a half h a plus b. Well, I can half the height to start with because a half of a h, well, the height is 4. Half of 4 is 2. And then I need to multiply that by a and b together. So multiplied by 1 plus 4. 1 plus 4 is 5. 5 times 2 is 10, and I'm in centimetres squared. All right, the circle. Okay, so I'm going to need a calculator for this, or I could write it in exact values of pi. So I'm just going to write it in exact values of pi. Let's give a radius. Actually, let's go across and give a diameter. Let's give a full diameter all the way across of 10 centimetres. So I need the radius to be able to work out the area of a circle. So formula, always write the formula down first. So I've got pi r squared. It kind of merges with my dress. Apologies for that. Let me try and move off the screen a little bit. You can see it better there. Hello. Pi r squared. Okay, so the diameter is 10. So the radius is half of that, which is 5. So to work out the area, I'm going to do pi times 5 squared. 5 squared is 25. So 25 times pi is 25 pi. Pi is just a number, remember. And I'm in centimetres squared as my units. And that shows you a basic run through of how we calculate the area of all these shapes on the screen today.